In this video, we will review Competency 17, which requires that a new teacher understands the relationships among probability theory, sampling, and statistical inference, and how statistical inference is used to make an evaluating prediction. We will also investigate the binompdf on our TI-84 calculator. In this situation, we need to satisfy the requirements of the binomial experiment. In order to do this, we need a word problem where we see n, number of trials, p, probability that is given or can be calculated, x, an exact number of required future events, then the outcomes must be independent of each other. The probability must be consistent in the problem. For this video, we'll need to use 3 particular problems. We need to deal with the mean, mu equals number of trials times the probability, standard deviation, square root of NP with 1 minus P. Variance is simply squaring the standard deviation. Then on our calculator, we will use the binompdf. So let's get started. Let's scroll up. Okay, number 1. An ordinary coin is tossed 12 times. What is the value of the mean and the standard deviation? Okay, mean is just our n, number of times, number of trials, and our coin, the probability for any coin is half. So that is 12 times a half. Well, we know that that's 6. But I recommend that during any given test that you go ahead and put that in the calculator. So that's times 1 divided by 2. Obviously, that'll be 6. This eliminates 2 of our choices. Okay, so we know we're between these two. If we go back up and look at what the standard deviation formula looks like, that's underneath the square root. So naturally, this is going to tell us B is our option, but we can go ahead and check this fact. Okay, so we have under the square root, under our radical, we have 12 times, and let's see here, that's 1/2, 1 divided by 2. Now we are also going to multiply that times 1 minus our probability, but we need to use our parentheses. 1 minus, and parentheses again, because we could run into an instance of order of operations issue. So that probability is 1 divided by 2. And we know 1 minus a half is a half. But just for calculator use sake. Okay. Our answer is still under the square root, though. We could calculate that all the way through and say 3. Now, let's just do a little comparison. So second, okay, we've got a radical, just put 3 under it. Same answer. We're good. Okay, number 2. An ordinary coin is tossed 12 times. What is the probability of getting tails exactly 6 times? Okay, for this, we will use our binompdf in our calculator, and we have that up above. So we need second vars and alpha math. Gets us right to it. Oh, look, we already have it entered. Okay, so we can enter. We have a half. There are 6 future times that we're predicting. So X is your prediction, and it has to be an exact number. It can't say more than or less than or anything different. And our probability is consistent. So enter, enter. Unfortunately, you enter again. Oh, this gives us a pretty extensive value, okay, which eliminates this one, this one. Be careful with B. Notice that is a terminating or truncate value, and we don't want that. So we need E. All right, number 3. Scroll up just a tiny bit. For number 3, we have an ordinary die is rolled 7 times. If a number less than 3 is rolled, what is the value of the mean and the standard deviation? Okay, we just use our formulas again. For the mean, it's n times p. P is different in this case. P actually is determined by a number less than 3. That's changing our probability. So that means we have numbers 1 and numbers 2, which is 2 over 6 or 1/3. Okay, you don't have to simplify this, put it in the calculator. So we have n is 7. 7 times, I'm going to say 2 divided by 6. Okay, that's repeating. That eliminates 2 options. We're left with C and D. Now we have to calculate standard deviation. And I'm noticing that we have one is an exact value and the other is an equivalency. I myself am going to lean towards the equivalency there, or the approximation rather. Sorry, approximation. Okay, so let's do this. We have second squared button, and then that's 7 times 1 divided by 2. Oh, nope, that's incorrect. 2 divided by 6, parentheses 1 minus parentheses 2 divided by 6. Notice that some of this you could do in your head and quickly enter, but for calculator use practice, I'm going to show you everything. You could have just said, 1 minus 2 over 6 is obviously going to be 2/3 versus 1/3. Whatever. Let's just go through the motions. Look, it is D. We are correct. Number 4. An ordinary die is rolled 7 times. What is the probability that the number is greater than 4, that a number greater than 4 will be shown exactly once? Okay, we have our n, and a greater number greater than 4 changes our probability. So our consistent probability, see, a number greater than 4, 4, 5, 6. Again, that's 2 over 6. And our x value is 1. Notice that's an option given in our answer choices. Okay, so this means in our calculator, we will have second VARS alpha math. Okay, in this case, we need how many trials? 7. Okay, enter. Okay, that is 2 divided by 6. Enter. And how many times do they want us to predict exactly one time of occurrence? enter, enter, enter again, and we have a reasonable value. And just out of coincidence, that is A. Number 5, the probability of a salesperson making a sale with any one customer is 1/3, 1 out of 3. If the salesperson averages 8 contacts per day, what is the probability that the salesperson will make 4 sales per day? Okay, so let's go back to the 1/3. What does this mean? One person or 3 people walk into the store. He's probably going to sell. He averages a sale of one person out of every 3 he talks to. How many people is he exposed to each day? Well, looks like he's got an 8 total of possible interest in his item he sells. And then we're saying, okay, let's see. What is the probability that he'll actually make 4 sales every day for a consistent amount of time? Okay, notice that our answer options actually say 4 each time. I haven't seen this type of answer on a test. It could happen. I think this is more for practice sake on possible practice questions. All right, let's put this in our calculator. So what do? We do second bars alpha math. Okay, how many total trials? That's what's going on. We have n equals 8. He equals 1/3. And our x equals 4. Okay, it's the 8 that's a little questionable. So this gives us 8. We enter. Now we need 1 divided by 3. And we enter. And how many future times? Our future is 4. Enter, enter again. Okay. Oh, it looks like we've got a good option. That will be C. Okay, let's move down to number 6. Okay, number 6. During the prior season, a basketball player makes 3 out of 8 of the baskets attempted. If the basketball player attempts to make a basket 20 times, let's write that down. N equals 20. Okay. In the next game, what is the probability that the player will make 11 baskets? So our X, our future amount, needs to be 11, and our probability is 3 out of 8. Okay, so we go to second vars alpha math. All right, so we have trials 20, enter. Our new probability is 3/8, enter. And our future attempts is 11, enter again. Do we have a candidate? Now be careful. See how some of these numbers are close? In our calculator, we have 0, 5, 0, 4, and another 0 after it. That means we can round to 4. So A is our option. Oh, and yeah, sometimes the eyeballs may be deceiving, but we're good. Number 7, the probability of a salesperson making a sale with any one customer is 1/2. If the salesperson averages 8 contacts per day, what is the probability that the salesperson will make 4 sales per day? Okay. Notice they have taken out our hint, but from the prior problem, we know that we're looking at X equals 4, exactly 4 people in the future, 4 sales. Okay, our P equals 1/2, and then we need our number of trials, 8 contacts, again, 8 possible people to talk to. Okay, so we know that, oh, let's clear this out. This is for something else. We don't want that. Okay, so what buttons are we pushing? Second, vars, alpha math, gets us right there. How many do we need? We need 8, and it's 8, enter. We have 1 divided by 2, enter. And our exact number for the future is 4. Enter again. Do we have a candidate? Yes, we do. Our candidate is C. Okay. Number 8. 3 cards are drawn from an ordinary deck of playing cards. What is the probability that none of the cards are clubs? Okay. This has changed things. Okay, we have 3 cards are drawn. Well, that has to be our number of trials. We're going to test out these cards by drawing 3. It's an ordinary deck. Okay, what is the probability? Okay, we have none of the cards, but clubs. That's where we find our probability. How many clubs are there? There are 13. How many cards in a deck? 52. Probability equals 13 out of the 52. Now we need to investigate our future, our X. None of the cards are clubs. That's a clue. It's 0. What's the probability of getting 0 clubs? No clubs. All the cards but clubs. That's what we need to think about and realize. Okay, so let's go through our buttons. Second, vars, alpha math. Okay, number of trials. 3 cards. We're trying out 3 cards. Enter probability. Well, we're interested in 13 out of 52. Enter. And we don't want any future events. Enter, enter, enter again. Let's see if we have a good candidate. Yes, we do with rounding. Round the 8 to 9. And that looks great. All right, let's scroll down to number 9. Right there. In a jar of 10 jelly beans, 8 are yellow, 1 is red, and 1 is green. Okay, so in a jar of 8 jelly beans. Well, I don't know that that's our trial. Let's keep reading. 6 jelly beans are drawn and eaten one at a time. What is the probability that exactly 2 of the eaten jelly beans are yellow? Okay, well, they left us a hint. We know what our X is. Okay, and our trials are where we're taking out jelly beans. So our N is 6. We know our X. Okay, our probability is what we need to deal with. Well, to get your probability, you go back and you look at what you're discussing. Yellow. How many yellow? We have 8 out of the 10. 8 over 10. Okay, that's going to be second vars alpha math. Our trials, we're pulling 6 out and we're eating them. Enter. Okay, our probability will be 8 out of the 10. And X is 2. Please notice that when I'm entering these in each time, I don't concern myself with simplifying. It isn't necessary. And on a test, basically, that's a waste of your time. Time is of the essence. So now we enter, enter, enter again, and we have a solid candidate. Notice we needed to round 0, 1, 5. Yes, we rounded the 3 here to a 4. So A is our candidate. And thank you. This will be the last one in this video, the last problem. Thank you for watching. Please look out for other videos related to this topic. It'll be competency 17.